Meet Mr. Griffith. Frederick Griffith was born 1877 in Cheshire, England. He was described as brilliant but reclusive by his colleagues. He published only a few papers in his lifetime. Little is known about the life of this famous biologist, but luckily his work survived past his death in 1941 due to a bombing in England during the war. His claim to fame was his 1928 paper that laid the groundwork for the transformation principle, and consequently impacted the research of a variety of other scientists who expanded on his ideas and discovered that deoxyribonucleic acid is the transformation agent in animal life. His findings also helped progress many cures for common ailments of the time, such as puerperal fever, scarlet fever, and infections from wounds after surgery.
In 1928, Frederick Griffith performed a series of experiments with bacteria responsible for pneumonia, called Diplococcus pneumonia. Griffith's experiment determined the mechanism of genetic inheritance, which other scientists had only narrowed down to the chromosomes located in the nucleus of most cells. During his experiment, a living organism, which was bacteria, had changed in physical form.
Diplococcus pneumonia is present in two forms. One is the virulent triple S strain with a smooth capsule essential for infection. The S strain of bacteria is able to infect and kill its host. The other form is non-virulent double R strain that lacks a capsule, giving it a rough appearance. The R strain of bacteria is easily defeated by the host immune system. Mice that are injected with the S strain die from pneumonia in a couple of days. Whereas the mice injected with the R strain continue to live. Mice also survive when injected with a heat-treated S strain, as expected, because the bacteria in the syringe are dead.
However, Griffith was surprised to determine that when he injected mice with a mixture of heat-killed S strain and live R strain bacteria, the result was lethal. Upon examining blood of the dead mouse, Griffith found R as well as S bacteria, both alive. The mouse ends up becoming infected and dying, even though neither of the bacteria in their states would prove pathogenic. Griffith's hypothesis was that the R strain bacteria had somehow been transformed by the heat-killed S strain. A transformation principle, as he called it, had transferred from the dead S strain to the R strain, and thus allowing it to synthesize a capsule and become virulent. The hereditary properties of the rough, non-virulent strain were changed, leading future scientists to investigate and to understand more of this transformation principle. This transformation principle was also linked to Mendel's pea experiments, opening the gates for understanding the passing on of genetic material.
Griffith's experiment was one of the first to suggest that bacteria could transfer genetic material through a process known today as transformation. Today we know that the transforming principle was the DNA of the S strain bacteria. The bacteria had been killed by the heat, but the DNA had survived and was taken up by the R strain. This was verified by experiments done by Avery, McLeod, and McCarthy, as well as Hershey and Chase.
As you can see, Griffith's experiments were crucial in the development of our current model of DNA. No mice were harmed in the making of this video.